This example will be to show you how to use calorimetry to find the enthalpy change of a reaction. So if I've got 25 grams of KCl added to water, this is what the situation looks like. Here's my calorimeter, and that calorimeter is full of 125 grams of water, and the water is at 49 degrees Celsius. And then to that water, I am adding potassium chloride, which is a solid. Well, when you stick potassium chloride in water, it's going to break apart or dissociate into ions, which will be K plus ions, aqueous, and Cl minus aqueous ions. And the process of this solid turning into all these different ions causes the temperature to go down to 47.2 degrees. So since the temperature of the water went down, we would say that this reaction happens to be endothermic. The surroundings got colder, so it is endothermic. And what I'm looking for is, the question says, what is the enthalpy change for the reaction? Well, here's my reaction, potassium chloride breaking apart into ions. And I want to find the enthalpy change, delta H, which is measured in kilojoules per mole. So I need the amount of heat that the KCl absorbed or released. In this case, absorbed because it's endothermic, and the amount of moles that caused that to happen. Let's find the moles first. Well, how much KCl was I given? I was given 25 grams of KCl, and I want to figure out how many moles that is. No problem. We know that 1 mole of KCl is a certain number of grams. If we look that up, potassium is 39.1 and chlorine is 35.5. So the molar mass is 74.6. When you divide those, 25 divided by 74.6 gives me 0.335 moles of KCl. And that's what I need right here. So for my enthalpy change, I need kilojoules per mole. I've got the amount of moles. Now I just need to find the heat. Well, in our lesson today, in our notes, we have 2 equations. We have the Q of the reaction is equal to negative Q of the surroundings, and the Q of the surroundings is equal to M times C times delta T. In this case, I know that I have 125 grams of water, and the water's temperature went from 49 to 47. So I know the mass of the water, the temperature change of the water. C, the specific heat, is a constant, so I know that as well. So I can find the heat, the Q, of the water simply by taking water's mass, 125 grams, times the specific heat of the water, which we know is 4.184 joules per gram Celsius degree, times the change in temperature. Well, final temperature, change in temperature is final temperature minus initial, or 47.2 minus 49. That change in temperature is simply negative 1.8 Celsius degrees. That goes right here, negative 1.8 Celsius degrees. When you multiply these 3 together, 125 times 4.184 times negative 1.8, we get negative 941.4. And if you check units, grams cancel out, Celsius degrees cancel out, we're left with joules. And that's what we measure heat in anyways, is joules. So this is the amount of heat that the water in our calorimeter over here gained. But what I really want is, what is the amount of heat that the potassium chloride lost? Well, this reaction, or this equation right here, says the Q of the reaction is equal to negative Q of the surroundings. So the two Q's are equal, you just have a different sign. So if my Q of the water is negative 941, the Q of the KCl is the same thing, but only positive. Now why is that? Well, if water absorbs energy, then the reaction must have lost it. In this case, the water gave up heat because it got colder, so the reaction absorbed it. But if one loses energy, the other would have to gain the same amount. So I've now figured out the Q of my reaction, KCl, is this. However, the units here are in joules, and I want my units in kilojoules, which is no big deal. We know that there's 1,000 joules for every 1 kilojoule. So if you simply divide by 1,000, we get 0.9414 kilojoules. I can plug that in up here, 0.9414. When I divide that, we get a delta H of 2.8 kilojoules per mole for that reaction. So that would be our answer, 2.8 kilojoules per mole. Now I ask you, what should be the sign for a reaction that we said is endothermic? Well, delta H's are supposed to be positive for endothermic reactions, and in this case, if you look right here, that's what we got, a positive value. If this was exothermic, if the temperature of my water here rose instead of dropped, then I would expect a negative value for the delta H.